you're going to be using it practically this whole chapter. But
When's mine?
Notebook.
Yeah.
how many didn't get the notebook?
Are you talking about this?
That one.
Alright.
I've got extra, because this is something that I keep a file in my room that anytime you need more, just let somebody's folder back there.
That's one.
Okay.
Already have one.
No.
Oh, it's missing.
Somebody in your row needs.
Two back there.
Anybody else in this row need one? Wyatt needs one? Everybody get one in his row? Okay. Now, I'll tell you right now, when it comes to the test on this, you're gonna have to know these 8 identities. That's one of my first questions. Name the 8 identities. It's not gonna be matching. I mean, if you don't know them, it's gonna be more difficult for you to do problems in this chapter. So you gotta get where you know what they are. Now, some of them are pretty common sense. Like, let's talk about it. Don't you know the sine is the reciprocal of cosecant? And you can use x, you can use thetas, you can use whatever to represent your angle. But couldn't this also be written, cosecant is 1 over sine? You don't need to really write these down because this is on that sheet. I'm just giving you to them in the way that you might remember, the ones that are easily thought about. What about cosine? What's the reciprocal of cosine?
1 over secant.
1 over secant. Or I could write it secant is 1 over cosine. What about tangent? What's its?
Cotangent 1 over
Sine.
Not that one yet. I'm asking what is its reciprocal, which would be cotangent. So that would be, then when you guys had to create your chart, do you guys remember having to do this on a test where, did you guys do the trig?
No.
Yeah, where you, like, if you wanted to put
Yeah.
how we're gonna put one all the same thing.
All you gotta do is be able to count 0, 1, 2, 3, 4, square root it, divide by 2,
Oh, you did.
and the cosine goes backwards? Yes?
We did it like a different way. I think we went like up and down instead of across.
Oh, well, if you go across, all you gotta be able to do is count. 0, 1, 2, 3, 4, square root it, divide by 2. So this is 0, this is 1/2, this is radical 2 over 2, that's radical 3 over 2, and square root of 4 divided by 2 is 1. And then the cosine is just that in reverse order. 1, square root of 3 over 2, square root of 2 over 2, 1/2 and 0, right? Then how did you find your tangent? You took sine divided by cosine, right? So 0 divided by 1 is
0.
0. So you just, that's one of the identities. Tangent is sine divided by cosine. So you've already used that one. You've really already learned it. So that's one of them. So if tangent is sine over cosine, then isn't cotangent cosine over sine? There's how many there? 1, 2, 3, 4, 5. So those 5 you should already know. Okay? Now, the remaining 3 are called the Pythagorean ones. That one you're going to use more than any others. More than these, more than anything else. Sine squared plus cosine squared equals 1. Now, if you can remember that one, you can find the other 2. If I want to find, let's say one of the other 2's. Legally, when you're working with equations, can't I divide or multiply as long as I did it to everything? Okay. So let's say I divide everything through by sine squared. Notice what happens. I'm just getting it set up. Sine squared over sine squared is
Cancel. No.
to 1, right?
1, yeah.
What's cosine over sine? Don't we know that's cotangent?
Yeah.
And what's 1 over sine? Don't we know that's cosecant squared? Look on your sheet. Isn't that one of the Pythagoreans, those first 3?
No.
See it? Now, what if I took that same equation and instead of dividing by sine squared, this time I'm going to divide by cosine squared. So what's sine squared over cosine squared? Tangent. What's cosine divided by cosine? 1. What's 1 over cosine? Secant. Now look on your sheet there. Isn't that one of them? So we have now named all 8 identities. The 5 you should already know, plus the 1, 2, 3 that you call the Pythagorean ones. And you can find them all from this main. Okay, now, you might want to write this down on that sheet of paper. By that I mean this. Up there by it. There are 2 other ways to write sine squared plus cosine squared equals 1, right? You see what I'm saying? I could solve for sine squared. So if I solve for sine squared, isn't that 1 minus cosine squared? Or could I solve for cosine squared? So if I solve for cosine squared, wouldn't I have to subtract sine squared from both sides? So 1 minus sine squared. So these 2 are another way to write that 1. So you may want to put it up there besides that one that's already there, because it's another format of that very first one. Do you understand what I'm saying, Mason?
Mm-hmm.
Okay. So that's something you may want to write up here by that one, because there's other 2 formats for it. Now, what about this one? Is there another way to write it? Could I solve it for cotangent squared? What would I do to solve it for cotangent squared?
Subtract 1.
Subtract 1. Okay. Could I solve it for 1? What would I do to solve for 1?
Secant squared minus.
Subtract cotangent squared from each side, right? So that would give me cosecant squared minus cotangent squared. So there's 2 other formats of this one. So there's 2 other ways to write each of those Pythagorean identities. And I'd write them down so you got them to refer to, especially when we start simplifying and verifying. Now my last one. Tangent squared plus 1 equals secant squared. What's another way I could write it? Could solve for tangent. What would I do to get tangent squared by itself? Subtract 1. So that would be secant squared minus 1. Or I could solve for 1. What would I do to get 1 by itself? What do I do to get 1 by itself? Subtract tangent squared from both sides, right? So it'd be 1 equals secant squared minus tangent squared. So there's another 2. On each Pythagorean, there's 2 ways to write it, besides the one that's given to you. You only have to know one way, but when we start verifying and simplifying, you may want to have those others to refer to, okay? Now, today we're going to be using those 8 identities to prove or to find a numerical value for a trig. So we aren't going to be really doing the main thing of the verifying identities yet. We're going to use numbers. So these are examples, and every answer you're going to have is going to be a numerical answer. Okay? And I'm going to give you quite a few examples, so you can do, and plus I have your test graded. As soon as we stop, I'll let you guys see what you made. I can't pass them back out to you yet because I still have some in the other class that haven't finished, but you can see what you made on it. And grades were good, so you're in good shape. Okay, which of the 8 identities would be helpful in finding the cosine if I know the sine? Which of the 8 identities could help me there?
Sine squared x plus cosine squared of x equals 1.
Well, and I forgot to say something to you, Richard. The other class was telling me that your head is in the way of the board a lot of the time, so.
They
could
made
you
sure to
move-
make that point quite clear.
Yeah. Have they told you? So you might move to another row whenever we're filming, so it makes it easier for them. Or either that or put, you guys aren't nice. Okay, does everybody agree? So what I wanna see on your paper is which of the 8 identities you're gonna be using. And on some of them, it's gonna be more than one. So that way you're gonna learn it as we go. So sine squared plus cosine squared equals 1. What this tells me is my answer is gonna be placed in which quadrant?
First.
First. And what do you know is true in the first quadrant? All students take calculus and all of them are gonna be positive. So what do we get for an answer is gonna be positive? Now, sine is 3/4. So 3/4 squared plus cosine squared equals 1. What would you do to solve for cosine? So this is just solving equations with numbers. When you square this, don't you get 9/16? Now what would I do to solve it for cosine? So subtract 9/16. So that would be 7/16, right? 1 take away 9/16. Now what do I do? Square root. So, and when you square root, isn't that normally positive or negative? Normally, but haven't we already established this as first quadrant? So we want the answer to be positive. So normally it's positive or negative, but you're going to be given what quadrant it is so you know which sign to take. So it's going to be a positive. I don't know the square root of 7, but I know the square root of 16 is
4.
And that's my answer. So every problem you're doing, you're going to involve one of the 8 identities to prove what the answer is going to be. So hopefully that gets you where you learn the 8 identities. That's my motive anyways. Okay, example 2. Okay, so you're given the secant, and you want to find the tangent. And what quadrant are we going to be in? We're in the 3rd quadrant. We're between 180 and 270. So that tells us where we're going to get our sine from. Now, which of the 8 identities works with a secant and a tangent somehow?
The second is square x equals tan square x plus 1.
So you write down the one you're going to be using. So does everybody agree secant squared equals tangent squared plus 1? That's one of the 8 identities. Now, we know secant is,
-3.
so you put that in place of secant. Now what's -3 squared?
9.
What would you do to solve for tangent?
Subtract 1 from the side. And then square root.
Square root. Now, we're thinking in the 3rd quadrant, what's the tangent in the 3rd quadrant? Is it going to be positive or negative?
Positive.
Positive. Now, square root of 8, what can I do with square root of 8? 2 square roots of 2. So there would be our answer. Okay, so we want to find the sine given the cotangent, and what quadrant are we in?
The 3rd quadrant.
3rd quadrant. So that's the first thing I do is identify the quadrant. Now, which of the 8 identities would be helpful here when I've got the cotangent, but I want to find the sine?
The cosecant squared x equals the cotangent squared.
Why would that be helpful? You're right.
Because cosecant is the reciprocal of sine.
That's it. So you've got to know which ones are the reciprocal trigs, because that's going to help. Does everybody agree with that one? Does everybody see why? If you want sine, you also can find cosecant. If I've got cosine, I can also find secant. If I have tangent, I can also find cotangent just by inverting them, right? Okay, so we know that cotangent is 5. What's 5 squared? What's 25 plus 1? Now what would I do to find the cosecant? Square root it, right? Because this is squared. And what's the cosecant in the third quadrant?
It's negative.
It's negative, so this is going to be a negative square root of 26. Now is that what we want? What do we want?
Sine.
So since I want the sign, I just have to invert this. But then we can't have a radical in the denominator, so we rationalize it. So you multiply both the top and the bottom by the square root of 26. And that would be our answer. Does everybody follow what I did there? Let's do which quadrant are we in? Fourth? Okay, now, we're given the cosine, and we want to find the cosecant, which
Is that 0.8?
is 0.8. There's motive to my madness. I want to make sure you guys use fractions here in just a minute. So which of the Pythagorean identities is going to be helpful there? The sine and the cosine, because if you know cosine, you know secant. If you know cosecant, you also know sine, right? So we're going to say sine squared plus cosine squared equals 1. Cosine's 0.8, but isn't that read 8/10? So doesn't 8/10 reduce to 4/5? So that's what I'm going to use. So what's 4/5 squared? 16/25. Now what would I do to get sine by itself? So if you subtract 16/25, what's that going to give you? What's 1 take away 16/25? What's 25/25 take away 16/25? 9/25. Now what would we do to find sine? Sine equals what? 3/5? We're in the fourth quadrant. What's the sign in the fourth quadrant? Negative. Now is that what we want to find? What do we want? Cosecant. So all we have to do is invert it. So negative 5/3. Okay, what I want you to do now, which that's all we're doing today, is you're getting used to using the 8 identities to find the specific trig. I want you to get your books open to that page 428, 25 through 36, and we're going to pick one of them to do together. Now, when will this assignment be due for you guys? Monday. Which you guys think looks like a good one? 29? Is 29 okay? Okay, let's see. Number 29. So we're going to read what it asks us and what's given us.
Cosecant of x equals square root of 11 over 3,
Equals square root of 11 over 3.
comma 5 over 2 is greater than x, and then less than, oh, sorry, it should be, I guess less than, and then pi, and then cotangent.
find cotangent? And I'm using x instead of phase. Okay, what quadrant are we in? Isn't that 90 degrees and that's 180, right? When you change from rads to degrees? So what quadrant is that? Second. So remember, we're second quadrant. Now, remember if you've got cosecant, we're given cosecant, we want cotangent. Which of those Pythagoreans might be a good one to use? Cosecant squared x. Does everybody agree that's a good one? Okay, now, let's sub stuff in. If I sub this in place of cosecant, what do you get when you square that? 11 ninths. When you square a radical, you get itself. When you square 3, you get 9. Now what do I gotta do to get cotangent by itself? Subtract 1. So what's 11 ninths take away 1? 2 ninths. Now we want cotangent, so what do? Instead of, we square root. Do you know the square root of 2? Do you know the square root of 9?
Yeah.
And what quadrant are we in? What's the cotangent in the second quadrant? Negative. So there would be our answer. Is everybody good? Okay. Somebody want to turn video off, and then I'd like to see your first 3 problems to make sure you're on the right track. So what would that be? Number 25, 26, and 27?